Good morning. This is Math 0310. It's April the 26th. This is the second to last lecture of the semester, so we are almost there. Some announcements here. Briefly, WebAssign. There's one last assignment on absolute value that will be coming up. That's not due until, as you're taking your final exam and everything, but don't let that one get away. For one thing, it's good practice for some of the problems on the final exam. Really good practice for some of the problems on the final exam. And so that would be a good assignment to look at for sure to finish up the semester. Exam 3, the window for Exam 3 shut down on Tuesday. I will be posting grades by Sunday. I'm really hoping, and I'm trying to put some pressure on myself, I'm really hoping to have your grades posted by tomorrow rather than by Sunday. So I'm hoping to post grades by Friday, which is tomorrow. I am out of town on Saturday, and so Saturday won't be getting anything done at all. So if I don't get them by tomorrow, then it will be Sunday for sure before they get posted. You remember they get posted on my WebAssign, on your WebAssign gradebook. As always, email me for a graded copy of the exam. Do not send me a remind message or a WebAssign message. If you will email me, that would be awesome, and then I'll give you your graded exam back. The final exam, the review is posted. We were talking about this just before the lecture started today. The review is on my Google site. That is a departmental final exam review. The answers are part of the review. It's easy to overlook that because it kind of looks like the rest of the review, but the answers are there also. They're not worked out solutions, but just answers. I do believe that if you go to the math department webpage, you can find worked out solutions there as well. And as always, if you have a question about a problem on the review, please get in touch with me and I'll be happy to help you with it. Either I'll meet with you on WebEx or I can send you a worked out solution. I have no problems doing that. Okay, the window for taking the final exam is May 3rd through May the 7th. Please note that there's a slight difference between that and the way I've done the other 3 exams this semester. The window, as always, opens on Thursday, but it closes on Monday for the final exam, not on Tuesday like it usually does. So I'm shutting it down on Monday because I need time to be able to get all the tests back and graded before the deadline for turning in grades at the end of the semester. So I have to shut it down a day early for that reason. So you do have through Monday, May the 7th to take the test. Online office hours. The rest of the semester are by appointment only. So please get in touch with me. I'll be happy to try to set up a time where we can meet in my WebEx office. I am also trying to schedule an 0310 help session that's online where I open up my WebEx office just for 0310 students, my 0310 students. So be looking for the time on that. It'll be sometime in the evening next week. It'll either be, my guess is either be Tuesday, Wednesday, or Thursday evening of next week. So be looking for that. Today, we are getting close to finishing up. We're going to go back and look at inequalities. We're going to talk about absolute value and then absolute value equations, and we finish the semester with absolute value inequalities next Tuesday. And we may even possibly get started with that today, depending on how things go. All right, so let's get started. So don't forget that we were talking about inequalities before exam 3, and so we've done some work with inequalities already. Don't forget that, let's see, we've talked about something basic like this: negative 2x plus 1 is greater than or equal to 3 times x plus 4 minus 8, something like that. All right, so that's a typical old linear inequality, right? All the x's are raised to the first power. We are not talking about quadratic inequalities in this class. Quadratic inequalities is a topic for college algebra. And so you may see quadratic inequalities there. Harder to solve than quadratic equations, when you're talking about a quadratic inequality. All right, so don't forget that here we're pretty much just treating this like a linear equation as far as how we solve this. You get rid of all the multiplication, collect all the like terms, get all the x's on one side, so I'm going to subtract 3x from both sides and get negative 5x plus 1 greater than or equal to 4. I'm going to subtract 1 from both sides, get negative 5x greater than or equal to 3. And then don't forget, this is one place where you have to be careful because we're going to divide both sides by negative 5. Here, remember, we reverse the order symbol. So don't forget that this is a place where you have to be careful. When you multiply or divide by a negative on both sides, right? Remember, that's the rule. Multiply or divide both sides by a negative. It has to be a negative number. You flip the order symbol. And that's not a just because thing. There's obviously a reason for that. And that is when you multiply or divide by a negative number, you're changing the sign of both sides. And when you change the sign of something, you're reversing the order that you've got. So, you know that 5 is greater than or equal to 3. That's a true statement. But when you have negative 5 and negative 3, what happens? Well, negative 5 is less than or equal to negative 3. Right? And so when you change the sign of both sides, so that's true also. That's true. This is true here also. But what did you have to do when you changed the signs of both sides? You had to reverse the order symbol in order to continue to make that true. So that's what's going on there. So this is x less than or equal to negative 3/5. So that's one way I want you to write out the solution to an inequality. You're saying that all the x values less than negative 3/5 are solutions to that inequality. Also, you could draw this out on a number line. I would expect you to be able to do that. So here's 0, here's negative 1, here's positive 1 on the number line. Negative 3/5 is a little bit past halfway towards negative 1 if you're starting off at 0. So negative 3/5 might be right about in here. And because it says less than or equal to, we put a solid dot there. And then we would shade everything to the left of negative 3/5 because this is less than. And so on a number line, that's what our graph looks like. So that's the second way I would want you to draw out an inequality or write out the solution set, is to actually graph it on a number line. So that's the second way right there. And then don't forget there's a third way, and the third way is I would want you to write this out in interval notation. And it's nice to have the graph in front of you for interval notation. And then so in this case, you have a left edge and a right edge in interval notation, and the left edge in this case is negative infinity. Remember, negative infinity is always what happens when you go off to the left forever like that. So this goes negative infinity to negative 3/5. Always a parenthesis around the negative infinity because you're not stopping anywhere. That's what a bracket says you're doing, is you're stopping somewhere, which you're not doing there. And then the negative 3/5 has a bracket because we are including negative 3/5. And so that would be the third way that I'd want you to write out a solution for an inequality, right? So inequalities, typically we use one of those three or all three of those ways of writing out the solution. All right, so we talked about that kind of problem last time. And then we also looked at what we called compound inequalities. Now, a compound inequality is one where you have two order symbols. So let's say we have negative 3 less than negative 2x minus 1 less than or equal to 7. All right, negative 3 less than negative 2x minus 1, which is less than or equal to 7. Now remember, this is what we call an AND statement. And this is shorthand. When it's an and statement, the word and goes between them. We usually write it in this shorthand form like I just did right here. And this is shorthand for negative 2x minus 1 is greater than negative 3, and negative 2x minus 1 is less than or equal to 7. Right? So that statement, that and statement, says the same thing as the problem I wrote down. We usually combine an and statement and put it together as one piece like that. Right? Take those two pieces separately and push them together and make it as one piece like that. Or statements, the word or, if it's between two inequalities, that you can't use this abbreviation for that kind of statement. Right? It doesn't work. All right, now remember the objective here is to still solve for x. And so we are adding, going to get the x by itself, so we add 1. You just have to remember to add 1 to all 3 parts of this inequality. We're going to work it out in the abbreviated form, not in the long form for the and statement. This is the way I want you to do this. So you have negative 2 less than negative 2x, which is less than or equal to 8. And then you're going to solve for x, and when solving for x here means you are going to take each of these 3 parts and you're going to divide by negative 2. But I am dividing by a negative, and we're invoking that rule we just wrote down above here. And so what must happen to these order symbols is they've got to flip. And so instead of less than and less than or equal to, you've got greater than and greater than or equal to. So you do the arithmetic and you get 1 greater than x, which is greater than or equal to negative 4. Now that's fine like that, but it's written backwards. You always want the smaller number. You always want smaller number on the left, because that's the way you write it out on a number line. And notice in this case, negative 4 is the smaller number between negative 4 and 1. You don't want it on the right side of the inequality. You want it on the left side of the inequality. So what you've got to do here is you've got to, it's like you're taking a pair of scissors and you're cutting along this dotted line here, and you're literally reversing the symbol, or the symbols. You're just writing it backwards. So when I do that, I start off with the negative 4, and I'm reading this from right to left now. You're reading it from right to left. So you have negative 4 less than or equal to x, which is less than 1. So notice you read from right to left, from right to left, and you're reversing everything. Right, and so that's what I did there. So now I've got it flipped over like I want it. Then the smaller numbers on the left. Notice the order symbols, because you're taking the whole statement and flipping it, the order statements at the end there also flip, because you're literally taking the whole statement and just writing it backwards is all you're doing. And so you get negative 4 less than or equal to x, which is less than 1. So that would be one way I'd want you to write out the solution on an and statement like that. And then on a number line, what that and statements like that always are talking about the x values that are between. Think about the word between there. And so we've got, let's see, we've got negative 4 here and 1 here. And so we've got all the x values between negative 4 and 1 are the ones that get shaded. Those are the ones that make both statements true. Right? They're both greater than negative 4 and they're less than 1. Now, negative 4 has got an equal to there. It's negative 4 less than or equal to x. So we put a solid dot in the negative 4. But the 1 is just less than 1, strictly less than 1, so you put an open circle there. Right? And that would be the second way to write out the solution set, is using a number line like that. And when you've got these and statements like this, it's always between the two numbers. That's the solution set. Finally, in interval notation, we would write this. This one's easy to write in interval notation because the edges of the interval are very nicely written down. So you have -4 and 1. Now the -4 is part of the set, and so that would be a bracket, and then the 1 is not part of the set, so that would be a parenthesis like that. And there's the third way of writing out the inequality like that, or writing out the solution to the inequality. So those are the solutions to this particular inequality. And obviously, as always, you can always take numbers out of that interval between -4 and 1 and substitute them into that inequality and make sure that they actually make it a true statement. So that's always okay to do. All right, so that's a second example here. Let's go ahead and kind of put a line through the page here in the middle to kind of separate these out. All right, so let's look at one more compound inequality. This is an OR statement. So one more compound inequality. This is an OR statement, the word OR there. And this one cannot be written in an abbreviated fashion at all. So let's say we have -3x plus 4 is greater than or equal to 2, or 5x minus 3 is greater than or equal to, we'll say that that's also 2. All right, so the solutions to an inequality like this one, or, are any x values that make either inequality true. They don't have to make both of them true. So all you do is you just solve each one individually first. Just treat each one as a separate linear inequality. So in this first one, you subtract 4 from both sides. You get -3x greater than or equal to -2. And then divide by -3. You reverse the order symbol, and you get x less than or equal to 2/3. X less than or equal to 2/3. And remember, you had to reverse the order symbol when you did that. And then on the other inequality, you add 3 to both sides, and you get 5x greater than or equal to 5. Divide by 5, you're dividing by a positive, so you don't worry about reversing anything, and you have x greater than or equal to 1. All right, so you are graphing. So this is the solution set as an inequality. So this is the first way to write it out. It's all the x values that make that statement true, and they make that statement true since it's an OR statement by just making one of those inequalities true. All right, and then on a number line, now 2/3 and 1 are really close together, so you have 0 here. So I'm going to go ahead and make that 1 right there, kind of really make the scale bigger. So the thirds, there's 2/3 right there. And so you have x less than or equal to 2/3. So we put a solid dot on the 2/3, and it's everything off to the left like this. And then everything greater than or equal to 1, so you put a solid dot on the 1, and it's everything off to the right like this. And that would be the solution set. And so notice it's all the values on the number line except the numbers between 2/3 and 1. So only a very small gap of values that are not solutions to this inequality. So there's the second way to write out the solution set. And then finally, the third way is an interval notation. And by the way, OR statements usually take this format, where they are two pieces kind of going off in opposite directions like that. And then finally, in interval notation, you just write out each piece separately. So this piece, that would be from -infinity to 2/3. -infinity to 2/3. You'd put a bracket around the 2/3 and a parenthesis around the infinity. And then this piece would be from 1 to +infinity. Put a bracket around the 1 and a parenthesis around the infinity. And then when you have two pieces like this, you always connect them with a union symbol like that. And that would be the third way of writing out the solution to that inequality. All right, so that is kind of goes back and kind of reviews, again, some of the things we've talked about with inequalities. So now let's turn our attention the rest of the semester, and you're going to see where inequalities, I mean, there's a reason why we've been talking about inequalities. It's going to come up again, everything we've talked about here. Here we go. What we're going to do is we're going to turn our attention to absolute value. This is the last thing we're talking about this semester. Now, absolute value, I'm going to kind of go back and review what absolute value even means before we start looking at equations and inequalities that involve absolute value. So absolute value, one way to define it is that it's the distance a number is from 0 on the number line. And because we're talking about a distance, distance must be positive. Right? So we use positive numbers for distance. So now, if this is a number line right here, here's 0 on the number line. And there's 1 and 2 and 3 and -1 and -2 and -3. And let's say that you were standing on 3 and I was standing on -3 like that. There's you right there. And here's me right here. Who is further from 0 here? Or what is the distance that each of us is from 0? You could look at it either way. Who is further from 0? And the answer here is neither one is, right? We are both the same distance. So both are the same distance. And so what that implies is that, this is 3 is 3 units from 0. -3 is also 3 units from 0. It just happens to be on the other side of 0. And so also 3 units. Right? And so what we say here is that the absolute value of those two numbers are the same. And the notation for absolute value, recall, is with vertical bars on both sides of a number. So this is the absolute value of 3 here. And so the absolute value of 3 is the distance 3 is from 0 on the number line. It's equal to 3. And the absolute value of -3 has got to be the same. It is also going to be equal to 3. Those two numbers have the same absolute value. The absolute values are both equal to 3. Absolute values are always positive numbers, right? Because it's defined as a distance, it's always a positive number. It's never a negative number. So the absolute value of x, no matter what x is always positive. Actually, technically, always positive, or it could also be 0, right? But it can never be a negative number. All right, so the absolute value of 8 is equal to 8. The absolute value of -8 is also equal to 8. Absolute value of 15 is equal to 15. Absolute value of -27 is equal to 27. Absolute value of 0 is 0 because it's 0 units from itself. Right? It doesn't matter if you have decimals or fractions. That doesn't affect things at all. So the absolute value of -3.9 is positive 3.9. All right. Now if you have a negative number in front of an absolute value, that has nothing to do with the absolute value there. That's just saying take the negative of whatever your answer is. So the absolute value of 4 here is still positive 4, but that negative sign just carries over and it says you're going to take the opposite of 4. So that would be -4. You're not saying that the absolute value is a negative number there, because that's just saying take the opposite of the absolute value. So take the opposite of the absolute value of 4. right? And so the absolute value of 4 is 4, so the opposite of that would be negative 4. So don't get worried about the fact that we're saying an absolute value is equal to a negative number, because that's not what that is saying at all. If you have a negative sign in front of this absolute value, it's exactly the same thing, right? The absolute value of negative 2 is 2, but this minus sign just carries over because you're saying take the opposite of the absolute value of negative 2. And so that would be negative 2, right? And so if you stick a negative sign in front of the absolute value, you're going to get a negative answer, because the absolute value is always going to be a positive number. All right, so that's really all there is as far as trying to define absolute value and what that represents geometrically on a number line. And so now what we're going to do is we're going to look at equations here that have absolute value in them. So these are what we call absolute value equations. Absolute value equations. So we're going to start off with some pretty simple ones here, and then we'll kind of go from there. So let's say we have the absolute value of x is equal to 5. Absolute value of x is equal to 5. And so we're looking for the numbers that make this equation true. Now, you're talking about distance here, aren't you? So what are you saying here? You're saying that if this is 0, you're looking for the numbers that are 5 units from 0. And there are 2 of them, aren't there? If this is 5 right here, that is 5 units from 0. And if that's negative 5, that's also 5 units from 0. So this equation has got to have 2 solutions to it, right? There must be 2 solutions, because there are 2 numbers that are 5 units from 0 on the number line. And so you get x is equal to negative 5 or x is equal to 5. Right? And so that's the solution set to this equation. It's 2 solutions, negative 5 and 5. All right, so that should start setting up a little bit about how this works out when you have an equation like this. So if you have a very similar equation, absolute value of x is equal to 3, then, without even having to draw out the number line, so that's what I'm going to do, but you can see that there are 2 numbers that have an absolute value of 3. There are 2 numbers that are 3 units from 0, right? And that would be negative 3 and positive 3. And so you get negative 3 or x equals 3 as solutions. And so you get negative 3 and 3, like that. As the solution set to that equation. Notice we're not using interval notation here, because this is not an interval. With inequalities, typically we don't try to write out even the number line solutions. I mean, you can if you want to, but the number line solutions drawing a picture here is just these 2 dots, right, at negative 3 and 3. You're not shading anything, because this is not an inequality. This is strictly an equation. So the interval notation doesn't come into play in this kind of problem at all. All right, so what are we seeing here? That if k is a positive number, if you have the absolute value of x is equal to k, then we can see that the solutions here are going to be negative k, or x is going to be equal to positive k, like that. Right? That's if k is a positive number. And we've seen that happen on the first 2 problems, right, for sure. And now if k is a negative number, so let me go ahead and put a box kind of around this statement right here. So what if k is negative? So what I'm talking about is a statement like this. Absolute value of x is equal to negative 3. Now remember, absolute values must be positive, right? If you have the absolute value of x, it must be a positive number, or 0. Must be positive or 0. So how could the absolute value of x be equal to negative 3 Well, it can't, right? That can't be true, ever. This can never be true, can never be true, because absolute values are always positive or 0. And so what's true here? That there's no solution to this equation. So in general, if k is negative, if k is less than 0, then the absolute, and you have an equation in that form, the absolute value of x is equal to k. K is negative, remember, here. Then what is the solution? Well, there's no solution to this type of equation. So we write no solution. So that kind of goes along with the first statement that I wrote, that I put the box around on this screen. All right. So now, then comparing two statements here side by side, if you have the absolute value of x is equal to 10, then the solutions here would be negative 10 or x equals positive 10. Right? That's our solution set, negative 10 and 10. If you have the equation, the absolute value of x is equal to negative 10, though, that would be no solution, right? There's nothing to do there. There's no way that that could be true. All right, so now let's kind of step this up a little tiny bit. Let's say we have the absolute value, not just of x, but of x plus 3, let's say, is equal to 6. The absolute value of x plus 3 is equal to 6. Well, it's still the same idea that we've been talking about, but there's two numbers that have an absolute value of 6 here. The two numbers are negative 6 and 6, right? Here's 0 here. Negative 6 and 6 both have an absolute value equal to 6. The difference is this is not x equals to one of those two numbers because the number itself is different. So what would we say here? That x plus 3 could be negative 6. Or x plus 3 could be positive 6, right? That's what's going on here. So that number line there doesn't give us the solutions. It's telling us what x plus 3 could be equal to, right? X plus 3 could be negative 6, or x plus 3 could be positive 6, like that. And so this one's not quite finished when you write this statement out. Then you solve each of these equations, and you get x equals negative 9, or x is equal to 3. You could certainly check those, right? If you check those, you get the absolute value of negative 9 plus 3 equals 6. So that's the absolute value of negative 6 equals 6. That is true. And if you check x equals 3, you get the absolute value of 3 plus 3 equals 6. That's the absolute value of positive 6 equals 6. That is true. Right? And so negative 9 and 3 are the solutions to this inequality. And now we still use the same idea that we've been talking about. It's just that the number inside the absolute values was different. It was a little bit more complicated. It was a little bit more complex as far as the way it was written. So we could state it like this, that is, if Bob is positive, and you have the absolute value of Bob, so you have some positive expression, and this is greater than, I'm sorry, I don't know why I said Bob is positive there. That doesn't have to be true. I'm sorry, if K is positive, and you have the absolute value of Bob is greater than or equal to K, then what would be true here? Then either Bob is equal to negative K, or Bob is equal to positive K, right? It'd be nice if I wrote this right. I'm not sure where it happened to my head there all of a sudden. So this is the absolute value of Bob is equal to K. I put greater than or equal to. The absolute value of Bob is equal to K, and K is a positive number. Like that. Then you get that Bob is equal to negative K, or Bob is equal to positive K. And if K is a negative number, see if I can write this one correctly on the first try. and you have the absolute value of Bob is equal to K. So now what are you saying? That K is a negative number. Then just like we've seen before, this is no solution. Right? Absolute value cannot be equal to a negative number. All right. So let's look at some examples and how this works out. So next problem, we have absolute value of x minus 6 is equal to 12. Absolute value of x minus 6 is equal to 12. So this is an absolute value equals a positive number, right? This is positive right here. And so what have we seen, like we saw in the last page, that this Bob, this expression inside the absolute values, can either be equal to negative 12 or to positive 12. So Bob is either equal to negative 12 or Bob is equal to positive 12. And in this case, Bob is equal to x minus 6. Right? And so what do we get here? That x minus 6 is equal to negative 12 or x minus 6 is equal to positive 12. That x minus 6 can have two different values and this be a true equation. And then just solve each of these equations. Add 6 and you get x equals negative 6. Add 6 here, you get 18. And so our solution set here, we could check them both, but they're going to both be solutions. You get negative 6 and 18 as the solution set for this equation. All right, so we have the absolute value of 3x plus 2, a little bit more complicated, equals, let's say, 19. The absolute value of 3x plus 2 is equal to 19. So this is a positive number right here. So what do we know here? That Bob, which in this case is 3x plus 2, can take on two different values and this be true. It can take on the value negative 19 or positive 19. And the absolute value of that number would be equal to 19. So that 3x plus 2 here can either be negative 19 or that 3x plus 2 can be equal to positive 19. And so you write out those two equations. 3x plus 2 equals negative 19. 3x plus 2 is equal to positive 19. And there is an or that connects these two statements here. And then to solve each equation, so you get 3x is equal to negative 21, or x is equal to negative 7, or, and then over here you get 3x is equal to 17, subtracting 2 from both sides, and then divide by 3 and you get x is 17/3. And so that would be the solution set to this inequality. It would be negative 7 and 17/3. All right, so we're making progress here. And again, for those of you who are with me live today, please stop me if you've got a question on how this is working out. All right, so we continue on here. Let's say we have this example. So each problem's been a little bit more complicated. So let's say we have 2 times the absolute value of 2x minus 6 minus 8 is equal to 6, like that. Now, see, look, this expression has got to be in this form, the absolute value of Bob equals k, like that. It's got to be in that form. So if it is not in that form, then you've got to put it in that form. So see, the absolute value must be by itself. So the absolute value must be by itself. In other words, isolated. All right, and so the first thing I've got to do here is I have got to add 8 to both sides of the equation. So you get 2 times the absolute value of 2x minus 6 is equal to 14. And then divide both sides by 2, and you get the absolute value of 2x minus 6 is equal to 7. See, you have to do that first before you can do anything else. Right now, this is in the form, the absolute value of Bob equals a constant. And this expression, this value right here, Bob is positive, right? And so that means we've got work to do to solve this equation because that's a positive number there. What do we know? That our Bob, in this case 2x minus 6, could either be negative 7 or positive 7. Right? 2x minus 6 could have one of those two values and make this a true equation. So that's what I write out here. The 2x minus 6 is equal to negative 7, or 2x minus 6 is equal to positive 7. All right, and then go ahead and solve these two equations. So you add 6 and you get 2x is equal to negative 1. Divide by 2, you get x is negative 1/2. In the other equation, you add 6 and you get 2x is equal to 13. Divide by 2 and you get 13/2. And so nothing wrong with there being fractions, by the way, as solutions at all. So negative 1/2 and 13/2 would be the solutions here for this particular equation. All right, so I think we're okay so far. So let's see. Let's say we have 3 times the absolute value of 5x plus 4 plus 10 is equal to 12. I'm sorry, not 12. It's equal to 2. That'll be better. All right, so same thing. We have to get the radical or the absolute value by itself, right? So you're going to subtract 10 from both sides of this inequality. So you get 3 times the absolute value of 5x plus 4 equals negative 8. And then divide both sides by 3, and you get absolute value of 5x plus 4 is equal to negative 8/3. All right, so this is a place where what have you got? You've got the absolute value of Bob equals k, but k is a negative number, right? So this is different than the previous couple of problems we've looked at. When it's equal to a negative number, remember, absolute value cannot be equal to a negative. And so we say here that there is no solution to this inequality, or to this equation, right? As soon as you see that you got a negative number there, there's nothing else to do there. Don't try to write anything else out because nothing else will be true here. You must have a positive number there. And if you've got a negative number, then you just write no solution and you're done with this, right? There's no way to solve this equation. No x values make it true. All right, so kind of watch for that. All right, the next problem. Let's say we have 8 minus 5 times the absolute value of 2 minus 5x is equal to negative 13. Okay, yeah, that's fine. We'll just say negative 13. All right, so first thing we've got to do is got to get the absolute value by itself. You have to have the absolute value of something, of Bob, must be equal to a constant like that, so you must get the absolute value by itself. Now, this one's written backwards from the last couple of problems, but you're still doing the same steps. The first thing, please don't subtract the 8 minus 5. Don't subtract these right here, first of all, because you would be violating order of operations when you do that. Because multiplication comes before, right? That violates order of operations. Multiplication comes before subtraction. Right, so don't do that. First thing you're going to do in this inequality, I keep on calling it an inequality, not sure why. This equation is you're going to subtract 8 from both sides. So you get negative 5 is times the absolute value of 2 minus 5x is equal to negative 21. Now, just because there's a negative number there, don't bail out yet. You don't have the absolute value by itself. So the next thing we're going to do is divide both sides by negative 5. And so you have the absolute value of 2 minus 5x is equal to 21/5. So that's a positive number right there, right? So we're okay here. We're going to have solutions to this inequality. And what's got to be true here, the Bob, the 2 minus 5x is either going to be negative 21/5 or it's got to be positive 21/5, right? That's the only way that this could be true. So 2 minus 5x is either equal to that value or 2 minus 5x has got to be equal to that value. Right? When you have positive number over there, you've got to write it out this way. Now you do have fraction arithmetic here, and so there's not really a lot you can do to avoid this. So you just have to kind of live with it. So I'm going to subtract 2 in both cases. This is negative 21/5 minus 2 here. And this is negative 5x equals positive 21/5 minus 2. Right? You're going to subtract 2 in both cases. You've got to get a common denominator, and this is 2 over 1. So remember, you're multiplying by 5 over 5 to get a common denominator. So you have negative 5x is equal to negative 21/5 minus 10/5 here. And on this side, you have negative 5x equals 21/5 minus 10/5. Same arithmetic as far as getting the common denominator. We had to multiply by 5 over 5 to get the common denominator there, which was 5. So this gives me negative 5x is equal to negative 31 over 5. And the other equation is negative 5x is equal to 11 over 5. And because I have a fraction, instead of dividing both sides by negative 5, what I would do here is I'd multiply both sides by negative 1/5. That would make my life easier here. And so this would give me an x on the left side there, and on the right side you'd have 31 over 25, and it would be positive. Do the same thing on this problem here. You're multiplying both sides by negative 1/5. So negative 1/5 there, you're multiplying negative 1/5 over here, and I'm multiplying. So that would give me positive x is equal to negative 11 over 25. Just multiplying those fractions together, so you're just multiplying the numerators and multiplying the denominators. And so the solution here would be 31 over 25 and negative 11 over 25, like that. And don't get too freaked out about the fraction arithmetic. I mean, you're not going to have lots of problems with the fraction arithmetic. Is going to be really, really messy or anything like that. So don't get too worried about that. All right, let's see. One last problem here on this kind of problem. So let's say we have similar kind of problem. Let's say we have 6 minus 3 times the absolute value of 2x minus 7 is equal to 9, like that. All right, so very similar problem to the last one. We subtract 6. We're going to get the absolute value by itself. And so you get negative 3 times the absolute value of 2x minus 7 is equal to positive 3. And then you're going to divide both sides by negative 3. And that gives you the absolute value of 2x minus 7 is equal to negative 1. And boom, right there, you've got a negative number. Right? As soon as you see that that's negative, you can stop. When you have the absolute value equals a negative number, you can stop and you write no solution. Right? There's no solution to this particular equation. All right, so kind of be careful about that, definitely. All right, so as far as practice goes, you should definitely be working on WebAssign. So there are some problems on the WebAssign homework on this, so practice. But the only problem with the WebAssign is that assignment also involves inequalities, which we haven't talked about yet. So that's one thing you can do, but you do have to be careful about those inequalities, and I would maybe skip those for now. But then more practice. And let me just give you a few problems here. All right, 8 problems here. And you might use these problems to practice solving inequality or solving equations that involve absolute value. All right, let's see. And so this, let me write down a few problems here, and then that will be all we need to talk about. All right, so that would be 8 good problems to practice right there. I'll certainly post solutions to those later so that you can see those, or I'll put them up in the notes in next Tuesday's lecture. So everybody have a really great week. Let me know if you have any questions. Please be in touch. I'll be happy to help you out anytime you need any help whatsoever. So please get in touch with me by remind, by email, by WebAssign. Thank you.